Now let's say we have a 3-equation system, and we'll say that we have, let's say we have x plus 2y plus 3z. Okay, and we'll say that we have is equal to 7. And we'll say that we have, at the same token, okay, we'll say that we have 3y minus 4z is equal to -1. And for the third equation, we'll say that we have x minus z is equal to 1. Okay, so if I'm looking at solving, let's say, through the use of matrices, okay, so setting up the system in terms of a matrix. Okay, so you got, okay, so if you notice we have with x, it is present in only the first and the last equations. Okay, so for the coefficient setup, we have 1, 0, 1. For what I have in y, okay, so we have 2 from the first equation, 3 from the second, but there is none from the last. And for what I have in the case of z, okay, so I got 3, -4, and -1. Again, the equations respectively we have set equal to 7, -1, and +1. Okay, so this is our matrix setup, or augmented matrix setup. And just looking at what we have now, and looking at solving for the system, and let's say that just getting it to where we have the use of Gaussian elimination. Okay, so I want 1, 0, 0. Okay, so for what we have in the setup, okay, again, there are various avenues that can be taken. In fact, there could be some situations where you can get to the Gaussian, you can sort of bypass the Gaussian elimination and go directly to the Gaussian-Jordan. But we'll just do, I'll show you both the Gaussian and the Gaussian-Jordan approach. In other words, both the row echelon and the reduced row echelon. Okay, so we got 1, 2, 3, 7 at the top, 0, 3, -4, -1 in the middle, 1, 0, -1, 1 at the bottom. Okay, so I want the first column to be 1, 0, and 1. And if I look at taking, let's say, the last row elements, I'm going to deduct everything from the first row. So you can see we have r of 3 minus r of 1 okay, so I still have the top row 1, 2, 3, 7. Then I have 0, 3, -4, -1. And again, we need in the adjustments, I have 1 minus 1 is 0. 0 minus 2 is -2. -1 minus 3 is -4. 1 minus 7 is -6. Right. Now, again, we have with the row echelon form. Okay, so I have 1 in the upper left-hand corner, and for the second row, I want 0 at the front, followed by 1. Right now, we've got 0 at the front, and I want to change this 3 to a 1. And so, looking at change up here, as I'm looking at getting closer to the row echelon form. So I can take 1/3 of the second row. So we have 1, 2, 3, 7. 1/3 of the second row, so we have 0, 1, -4/3, and 1/3 of -1 have -1/3. 1/3. Okay, and looking at what we have in the development so far. Okay, so we got in this particular layout, and just copy this matrix from the last stage we have here. Okay, so I got 1 in the upper left hand corner, and I want the next row to be 0, 1, and now I want the third row to be 0, 0, and 1. And what I can do here is I can eliminate the presence of -2, okay, by adding 2, and it can be either through adding directly to the first row or adding twice the second row. And my recommendation would be, since I want to stick with integers as much as possible, we can just add R of 3 and R of 1 together. Okay, so for what we have at this juncture, okay, now I want to make this last row 0, 0, and 1. And so what I'm going to be looking at here, okay, so I'm going to have to interact the third row with the second row, because if I interact with the first row in terms of adding or subtracting, guess what? That 0 is going to end up becoming non-negligible, and I want to preserve that 0. So what I can do here, I can make the -2 into a 0 if I add 2. So this will be in the case of adding twice the second row. So here I'm going to have R of 3 plus 2 times the second row And if we do this, okay, so you got 0, -2 plus 2 is 0, -4 plus 2 times -4/3. Okay, that's going to be a -20/3. And -6 minus 2/3. Okay, and so in this case, that's going to be another -20/3. And what I can do here, okay, so I almost have the row echelon form. And I can make this -20/3 into a 1. So what I'm going to do here, I can get rid of this non-integer. Okay, so I can multiply the third row by -3/20. And multiplying this last row by -3/20, and we have 1 and 1. So going back to what we have in the system, okay, now this last result at this stage, okay, again, that is going to be the row echelon form, okay, and so what this is saying here is that for this particular stage, right, so you have in the layout, okay, so you have from the top row, you have x plus 2y plus 3z is equal to 7. You have y minus 4/3 of z is equal to -1/3. And we have with the last row. Okay, this signifies that z is equal to 1, and you can back substitute and solve for y. If we back substitute into the second equation, and once you get y, you can back substitute the values of y and z into the first equation and solve for x. That is one way, being able to solve completely what we have for this system. But now if I decide to continue utilizing matrices, and go with the reduced row echelon form, so just looking at zooming in. Okay, so again, with the reduced row echelon form, I want 1, 0, 0, and then moving the 1 diagonally, I want the top row to be in the second column value to be where we have 0. Okay, so I want to read out 1, 0, 0, 0, 1, 0, and 0, 0, and 1. So what I can do here is that I can convert the 2 from the top row into a 0. And so in this pathway, I can say that I have R of 1 minus 2 times the second row. And for what I have here, so I'm still going to have 1, 0, 0, okay, so you got 1 minus 0 is 0, 2 minus 2 is 0, 3 minus 2 times 4 thirds. Okay, so that's going to be 3 plus 8 thirds, and so we're going to have 17 thirds. And for 7 minus 2 times negative 1 third, okay, that is going to be 7 plus 2 thirds, or 21 thirds plus 2 thirds. Okay, so we're going to have 23 thirds. Okay, so I now have 1, 0, 0, 0, 1, 0, and I want 0, 0, and 1. So what I can do here is that we have with the top row. Okay, so I'm going to make this 0. So I can say that I have, so I need to deduct 17 thirds. So I can say that I have R01 minus 17 thirds of RF3 and for now, instead of doing this simultaneously, I'm going to leave the second row as it is at the moment. Okay, but just looking at what we have now. So you got 1 minus 17 thirds is 0 is 1. You got 0 minus 0 is 0. 17 thirds minus 17 thirds, that is going to be 0. Now 23 thirds minus 17 thirds times 1, that'll be 23 thirds minus 17 thirds, which will be 6 thirds, and that is going to go to 2. And then we have, as we get closer to the final dismount, okay, so the only remnant left, okay, is with the second row. Okay, and so just going back. Okay, so now again I have 1, 0, 0, 0, 1, 0, and now the negative 4 thirds needs to be converted to 0, and so we have in the follow through. Okay, so that which will eliminate the presence of negative 4 thirds will be positive 4 thirds. So I can say that I have R of 2 plus 4 thirds times R of 3 Okay, so you got 0 plus 4/3 of 0 is 0. 1 plus 4/3 of 0 is still 1. Negative 4/3 plus 4/3 of 1. Okay, we're going to have additive inverses. So negative 4/3 plus 4/3 is 0. And negative 1/3 plus 4/3 of 1 will be negative 1/3 plus 4/3, which will be 3/3. And so this is going to go to 1. And so for what we have in the overall picture, so this is the system of equations, okay, we were dealing with. And for what we have, just kind of putting back, and I'm just going to put this in a rather large display. And again, this portion here, okay, that's going to be the reduced row echelon form. And so for what we're going to have for the solution, okay, so 1, 0, 0, 2. Okay, so the 1, 0, 0, 2, that means we're going to have the x is equal to 2. 0, 1, 0, 1 means that we have 1y is equal to 1. And the 0, 0, 1, 1 again stresses that we have z is equal to 1.